multiple companies that Horst has had the pleasure of partnering with his photogrammetry experience. What do I mean by an industrial approach? I was at Inserter. I was with Inserter at an event in London a few months ago, and there was a doctor there sharing that he had a stereo photogrammetry device, and he had just been using it for about 7 months. I asked the doctor how many cases he had completed with that device, and he told me about 25 cases. And I asked him how they've turned out. How have they been? And the doctor shared with me that 3 of the cases were not passive. 3 of the cases, he had to reappoint the patient, start the process over again, and basically take measurements, take impressions, and create a prosthesis for that patient. So ultimately, his failure rate was 10%. So three cases out of the 25 that he'd completed. And when we think about the companies in the middle of the screen there, Airbus, Boeing, would we get on a plane if there was a 10% chance that the plane would crash, wouldn't function properly? Of course not. Or would we get into a Porsche or a Toyota if there was a 10% chance that the brakes wouldn't work? Of course not. So when we talk about an industrial approach to photogrammetry in the dental space, we want a 0% failure rate. And so that is our commitment to our customers, that we guarantee a passive fit. If you follow our IFUs for use and you follow our protocols exactly, we guarantee a passive fit every single time. So Imetric as a company, we started back in the early 2000s, mid 2000s, started with an idea around desktop scanning, and I'll talk about that in a moment. And we evolved from desktop lab scanning into the handheld iCam that you see today. We started clinical trials back in 2013. We conducted market tests in 2018, and we launched mainly in the US market in 2019. And we are now the #1 photogrammetry device globally in the dental space. But as I mentioned a moment ago, we do have a background in lab scanners. And it's important to mention this because lab scanners have always been regarded as the gold standard for precision and accuracy when it comes to taking an impression or taking a measurement of implant positions. And we feel and we know that with the iCam, we have now essentially transferred that level of precision and accuracy from a desktop scanner into the handheld unit that you see in this presentation, which is the iCam unit. I also show this because we have a long history of working in this space, dating back to 2007. So we have a lot of experience in working with precision and accuracy and ensuring you have the best possible outcomes clinically when taking a measurement with the iCam. We work closely with the Whitecap Institute in Utah back in the 2013, 2014 era. But it's important to note that at the bottom of the screen there, iCam 4D with 4 cameras. When Horst launched this product, he knew that he wanted to create a device that offered true photogrammetry. And to be considered true photogrammetry, you need to have at least 3 cameras that are moving. And this is very, very important. And I'll come on to this in a moment about some of the other softwares or technologies that are out there that have limitations in their design without having the number of cameras needed to be considered true photogrammetry. So what is photogrammetry? Photogrammetry is the science of obtaining measurements from photographs. Very, very simple. What does photogrammetry actually do? Photogrammetry works by taking a series of photos or measurements of an object, structure, or landscape from different points or angles. Okay, so those are considered the explanations for photogrammetry in any industry, not necessarily just dentistry. But in dentistry today, photogrammetry is kind of a buzzword. For those of you that were at the IDS conference in Cologne, Germany last year, every booth seemed to have a different type of photogrammetry system, mainly with intraoral scanners, some with smartphones. Photogrammetry has really become a buzzword in the full arch space and in the industry that we work in every single day. But photogrammetry is not a new technology. Photogrammetry was being used back as far as the First World War. So planes would fly over the trenches and they would take images of the trenches with a camera, multiple images at a certain series, and those images would be stitched together to create maps of that environment, much like the image that you see on the screen here. One of the challenges with this type of photogrammetry, when you're stitching those images together, it can be very challenging to get the exact overlap that you need to have the highest levels of accuracy and precision. And I'll talk a little bit later on about how iCam works and how it's different from this methodology. But ultimately, when you're taking a measurement of a landscape is immobile. It doesn't change, it doesn't move. Okay, so if you're taking a series of pictures of the landscape, it's much easier to stitch those images together to create the mapping that you're trying to do. It's much harder in dentistry because obviously you're not working with a stable environment. You're working in the mouth, you've got blood, you've got sutures, you've got a tongue, you've got tissue to deal with. Very, very hard environment to be working with. Excuse me. There is actually another device on the market today that uses stitched photogrammetry. It's called the Shining 3D. You may have heard of this either at trade shows or from their marketing efforts. Essentially, the Shining is using the technology that I just showed you. It's taking a series of pictures, stitching them together and overlapping them together to create a measurement or an image, a 3D image of a certain space. In this case, it's an edentulous arch with multiple implants placed. Again, when you're stitching images together in an immobile environment, i.e. a landscape, it's much, much easier to do. In the mouth, as you can see here on the screen, it's a very, very difficult environment to work in. And so it's very important to understand that just because something is photogrammetry, not all photogrammetry is created equal. And there's a lot of differences and nuances between the different systems. This is what it looks like when you take an image using the ICAM system. So again, very, very challenging environment to be taking a measurement in, but I'll go into the science behind ICAM and explain why it does such a good job of taking the implant position so precisely and so accurately. So when we think about full arch cases and full arch success, as a surgeon, you can complete the best surgery possible. You can complete a quad zygoma surgery. You can complete an all-on-6 in the maxilla with pterygoid implants. You can put your implants exactly where they need to be, the proper levels, and everything can be absolutely perfect. But from that point, what is the most important aspect of the case? What is the most important part of the next stage of the procedure? It's to guarantee that you have a passive fit. Because ultimately, if you don't have a passive fit, you could potentially be putting strain onto those implants that you have so accurately placed and taking so much time to ensure that they're in the exact place that you want them to be. So there are lots of different ways in which we can measure implant positions in full arch implant therapy today. We've got the analog verification jig technique, which has been around a very, very long time and has worked successfully. We've got digital intraoral scanning with scan bodies, and we'll talk a little bit about this later on. You have grammetry products such as OptiSplint and others. You've got stereo photogrammetry. In this case, we're showing the markers for the micron mapper, and I'll talk a little bit about stereo photogrammetry and the difference between stereo photogrammetry and ICAM true photogrammetry in a moment. You've also got intraoral photogrammetry, such as the Shining 3D system. And then we have ICAM true photogrammetry. And I'll explain why we consider it to be true photogrammetry in a moment. So for the doctors on the webinar this evening, normally I give this presentation in a room and we can have a discussion. But how do you know the prosthesis is passive? When you seat the prosthesis, whether that be the temporary, immediately loading provisional, or your final, how do you know it's passive? One of the pieces of feedback we once got at an event in the US was it screws in. That is obviously the wrong answer. If we're gauging whether it's passive or not just because we're able to get the screw to engage and screw down, that is not how we ensure that the prosthesis is passive. And we'll talk about some of the challenges that we have as clinicians, or you have as clinicians and as dental labs, as you're looking to deliver a passive fitting prosthesis every single time. Because ultimately, we want to eliminate strain and create even contact across all of our MUAs or across all of our implants. We don't want any tension or strain being put onto those implants that could lead to failure down the road. And typically, you don't see those failures straight away. I was in a presentation in Bristol last week, and there was a lab owner present in the room, and he shared that he's starting to see a lot of single implant failures on his full arch cases that are about 4 to 5 years old. And he thinks that those implants have been under strain over a long period of time, and ultimately something had to give, and the implant has actually failed rather than the prosthesis. So it is critical that we ensure there is no strain being put on those implants through the delivery of our temporary or final prosthesis. So ultimately, there are some enemies that you face when you're trying to ensure that your prosthesis is passive every single time. The first is the inability to detect with the naked eye or by feel whether it's passive or not. I worked very closely with ClearChoice out in the United States. They've got 107 locations across America, and they only place implants, majority of the time full arch. They typically do about 3 full arch surgeries every morning across all 107 locations, and then every afternoon they're delivering their final prosthesis. The clinical director of ClearChoice shared with me one day, Gareth, there is no ruler for passivity. There's no way of verifying if something is passive or not. It's clinical judgment, and often it's just hope, and also just really hoping that prosthesis is passive and has been designed the most accurate way possible. So as we mentioned a moment ago, just because it screws in doesn't mean it's passive. The standard for passivity in many of the journals and literature states that about 100 microns is about the threshold for whether a prosthesis is passive or not. And obviously 100 microns is about the width of a human hair. So we are talking about very, very small tolerances here between what could be a successful prosthesis and what will ultimately be a non-passive prosthesis and putting strain onto our implants. And this is a quote that a lot of our engineers like to discuss internally. The absence of evidence is not the evidence of absence. You may have completed hundreds of cases, full arch cases, and not seen any issues, but that doesn't mean that the prosthesis isn't passive or is passive. And as the lab owner shared with me last week, he is starting to see some cases fail now that have been in the mouth in the last 4 to 5 years. So these issues won't be seen overnight. You'll see them, 3 to 5 years down the road if there are issues with passivity. So the first challenge we have is, how do we know that prosthesis is truly passive or not? The second is the concept of tolerance stack up. So as we think about the entire workflow from placing your implants to delivering your final prosthesis, there are a lot of steps along the way. Okay, and there's this concept that each step introduces a tolerance. So when you think about our lab scanner, for example, I lived in the United States for about 14 years. I lived in Arizona where it's very, very hot. If you take an impression of a patient in Arizona and put it into the back of the courier's car, that impression is going to change shape. Okay, so you've introduced a tolerance. You then get the impression back in the lab, you pour that impression up in stone, you've introduced another tolerance. You then measure that stone model with your lab scanner. You've now introduced another tolerance. So just by converting the clinical situation to a digital file, you've introduced various tolerances. And so if we think about this in a digital workflow, there are lots of steps in this process, and there are certain tolerances that we can expect to see. So for example, with full arch intraoral scanning, you can see anywhere from 100 to 400 microns of inaccuracy just from taking your impression with an intraoral scanner. That is a substantial tolerance that has been introduced to the process. If you then 3D print a provisional, 3D printers typically have anywhere from 50 to 150 microns of tolerance. You've introduced another tolerance stack up into the process. And so by the time we get to the final prosthesis, we can actually have a cumulative tolerance that would lead to the prosthesis not being passive. Excuse me. So if you look on the left side of the screen here, you've got your ICAM measurement, which typically will be in the 5 to 10 micron range of precision. Let's say you're going to mill a zirconia prosthesis, and then that zirconia prosthesis needs to be sintered. Typically, that'll be a cumulative tolerance of anywhere from 40 to 80 microns. So that's considered by many as the gold standard for restoring a full arch. Now, if we look at the example on the right side of the screen, where we take an intraoral scan, intraoral scanners are known to have a potential tolerance of anywhere from 100 to 400 microns, and we've got some data to show you later on to support that. And then with a printed restoration, you can have tolerances of 50 to 150 microns. And let's just say you're cementing your prosthesis onto tie bases. You can easily end up with a cumulative tolerance of 200 to 600 microns, which is obviously over 0.5 millimeter. So the method you use to take the patient from surgery to delivery is very, very important in terms of those tolerances that can all be combined and ultimately lead to whether you have a passive fit or not. The third enemy is the human body. Many of you that went through dental school and are dentists on the call will remember mandibular flexure. Okay, this concept that when a patient opens wide, the mandible flexes and essentially can change the shape of the mandible jaw from as much as 0.4 to 1 millimeter. So let's think for a moment. If we're taking a digital impression with an intraoral camera, okay, we're placing that intraoral scanner into the mouth. We're asking the patient to open nice and wide. What are we doing to the mandible? We're now flexing the mandible from anywhere from 0.5 millimeter to 1 millimeter, and we're measuring those implant positions for our full arch in the flexed position. We're then sending that to our lab to make a prosthesis, and they're going to make a prosthesis in the flexed position. And then when you seat the prosthesis at delivery, patients open wide, you try it in, it feels good, but then when they close, now you've got tension on your implant. So, all dentists were trained at dental school to take an impression at the rest position. We certainly aren't doing that when we're scanning with an intraoral scanner, and this is especially important for full arch implant cases. The other issue with the human body is that we run at about 37 degrees centigrade, and a lot of the materials that are used for the scan bodies can change shape due to the temperature of the human body. So if we look at the image on the screen here, down at the bottom there, a lot of the horizontal scan bodies that you see on the market and some scan bodies for photogrammetry, stereophotogrammetry, are made of PEEK plastic. PEEK plastic can change shape by as much as 60 microns just from putting the scan body into the human body. And we talked earlier on about the fact that we've got about 100 microns is our maximum tolerance that we can go to. Just from putting the plastic scan body in the mouth, it can change shape by as much as 60 microns. So if you think about a case in the mandible where you've got an intraoral camera scanning a plastic scan body, you've got mandibular flexure changing the shape of the mandible, and then you've got the human body temperature changing the shape of the scan body, you can see how this will lead to inaccuracies. You've got other products like aluminum, which is used with the Shining 3D product, that can change shape by as much as 24 microns. And then the iCam body is made from titanium alloy and most importantly is vertical, and it only has a tolerance of about 9 microns. So we have really done everything we possibly can to ensure the highest level of precision and accuracy. Enemy number 4, all photogrammetry devices are equal. We get this a lot. A lot of people think that all photogrammetry is the same thing. And it's very important to understand the differences and the nuances between different types of photogrammetry. So we have iCam photogrammetry on the left here, and then we have stereo photogrammetry on the right. When I talk about stereo photogrammetry, I'm talking about the tuple, I'm talking about the PIC, I'm talking about the micromapper, and I'm talking about the OXO. Typically, they have 2 cameras. That's one of the easiest way to tell if you're working with a stereo photogrammetry device, versus the iCam true photogrammetry device, which has those 4 moving cameras as we're taking our measurement. You also have the material that the scan body is made from. We talked about this a moment ago. A lot of products in the stereo photogrammetry space are made from plastic or the aluminum that we shared just now. There's also the calculation method. So when a stereo photogrammetry device is taking a measurement, it's essentially taking images and averaging that data to arrive at a final measurement of those implant positions. So it's averaging 3D data. The way that the iCam works is it calculates coordinates. All 4 cameras are looking at all of the targets in the mouth at the same time to get the average coordinate values of those implant positions. So it's a very different calculation method being used. And when we look at the precision values between iCam true photogrammetry and stereo photogrammetry, iCam typically is within 2 to 5 microns of precision, and stereo photogrammetry can be as much as 20 to 60 microns. The thing to think about here is a human red blood cell is about 8 microns in size. So this is the level of precision that we go to with the iCam. We are obsessed with precision and accuracy, and this is how we get to the point where we can guarantee a passive fitting prosthesis every single time. So are all photogrammetry devices equal? If you look at something from just one direction, it doesn't tell you the full story, right? So if we look at the screen here, it looks like Prince William is flipping off the press after the birth of one of his children. We're just looking at something from one angle and one direction. But when we actually evaluate from all positions and all angles, we see the true story. We see that he's actually saying, this is the birth of my third child. And this is the best analogy that I can use to kind of describe the difference between stereo photogrammetry and intraoral photogrammetry, which typically just looks at the targets from one position, and then ICAM true photogrammetry, where we're measuring those targets from different angles. And if you think back to the terminology that I quoted at the beginning of the presentation, a photogrammetry is the measurement of positions from different angles. And those different angles are very, very important. So if you look at stereo photogrammetry, typically you've got two cameras measuring a flat surface. If you're measuring a flat surface, it can be very challenging to know whether your implant is leaning forwards or leaning backwards. And that angle is so, so important to the passivity of your final prosthesis. So when you look at the design of many other stereo photogrammetry devices and their scan bodies, often they use a flat surface. So the one up in the top left here is the PIC flag. It is a flat flag with only 4 targets. So again, it's measuring that flat surface. Excuse me. Over on the right here, you've got the micro mapper. Again, a flat surface. It's very, very hard to tell when something has a particular angle with it. And then the two-pull, same challenge. You've got a round scan body, but because it's round, it still appears flat to a camera. So it's not actually able to tell you with multiple surfaces what the angulation is of that implant. If you look at the ICAM body on the lower left here, you'll notice it has 4 sides to it, and we actually want to scan 2 surfaces when we take our measurement, and that is one of the ways in which we get to the level of precision and accuracy that we do. So when we think about ICAM true photogrammetry, we are truly measuring all the angles of those implant positions with those 4 moving cameras as we orbit around the patient, capturing those 2 surfaces of the ICAM body as we orbit. And I've got some images now to show you what essentially is happening. So as I mentioned a moment ago, you've got those 4 cameras. Each camera is measuring the targets on each implant at the same time. Okay, so we're not taking a series of images and averaging the data or stitching it together. We are measuring where all of our implants are in space at the same time with all 4 cameras. And this is sort of a big difference between the ICAM true photogrammetry system and all of the other systems on the market. And this slide here is quite telling. Okay, so when we look at a 2-camera system, which is basically pretty much everything else on the market, and let's just imagine we're scanning or measuring 4 implants. Here they're called targets. That system is going to do roughly 128 equations of where those 4 targets are in space. If they had 8 implants, it would be roughly 256 because it's taking those pictures and averaging them together. Because the ICAM is so different in the way that it works, we're capturing about 61,000 equations as we're measuring where those implants are, each camera measuring the target at the same time. That is the level of information that we are capturing with the ICAM. I often get asked, why do you need to have the cable on the back of the ICAM? Other systems are sort of handheld and mobile. This is part of the reason why. We're capturing so much information and so much data. This is another way in which we capture the level of precision and accuracy that we do. It's because of the information that we're capturing and the amount of information. Another important part of photogrammetry or true photogrammetry is calibration. Okay, so other companies may say to you, doctor, the great thing with our product is you don't need to calibrate. Let me sort of give you a couple of analogies here. When I lived in the US, I used to fly usually 3 to 4 times a week. When I got onto the plane, I would always look to the left and sort of look at what's going on in the cockpit. And I would always see the co-pilot in the right seat pressing buttons with his paper out, checking everything. He was essentially calibrating the plane. She was making sure that before taking off and climbing to 30,000 feet, everything is working correctly. That's the best analogy I can use here, that prior to taking a measurement and sending it to your lab, we want to verify that the iCam is working correctly. We want to make sure everything is working as it needs to before you send it off to the lab. What I always say to my clients is, as a clinician, when would you like to find out that your prosthesis isn't going to fit? When would you like to find out that it isn't going to be passive? Would you like to find out when you go to seat it? Or would you like to find out when you calibrate the iCam and potentially find out that there's an issue? And the issue might be that it hasn't heated up correctly, or it may need a software update or something along those lines. But it's better to find out at that point versus when you get the prosthesis back from the lab and a patient is expecting to leave that appointment with their new smile. So following calibration, we then take our measurement. One of the things you'll find with the iCam is it's extremely easy and efficient to use. We use a traffic light system. So once we start measuring, the iCam bodies will appear red. And as we orbit around the patient, as you can see on the screen here, they'll turn orange and then ultimately green. The software is giving you real-time feedback, letting you know that you're capturing the correct information and when you have enough information. And typically an iCam measurement will last anywhere from 20 to 30 seconds. So we'll talk a little bit in a moment about the efficiency gains that you'll see from iCam, not just in the time that it takes to take a measurement, but also the overall procedure time as well. And this is what the iCam looks like clinically. So ultimately, we're just looking to capture those targets in space, making sure that they're positioned within the circle on the left side of the screen there. Notice the targets start off red, they turn orange, letting you know you're capturing the correct information, and then ultimately green when you've captured two surfaces of each iCam body to the correct level. Very, very simple to use. And this is something that can be delegated to team members or anyone within the clinic or lab to do, because it is so straightforward and so easy. So we've talked a little bit about iCam true photogrammetry compared to stereo photogrammetry. Now let's think about analog workflows versus iCam photogrammetry workflows. Many of you may be currently taking your implant positions using analog techniques, or maybe your labs that are going out and doing conversions, day of surgery. Let's think a little bit about that workflow and how it could be different. So is it possible to convert a denture day of surgery so that the patient leaves with teeth after their surgery? Absolutely. Of course it's possible for a patient to leave day of surgery. But is it the preferred method? Is it providing the best possible clinical outcome and solution for that patient? That's something to discuss and to think about. One of the challenges with the analog conversion process is there are obviously lots of steps in that process, and it's highly technique sensitive. So much so that quite often dental labs will actually go out to the clinic and carry out this process on behalf of the surgeon, because it is so technique sensitive and because it is so time consuming. There are lots of steps along the way. Excuse me, just getting over a cold. There are a lot of steps along the way. And ultimately, the challenge with analog is you can get all the way to the end of the process. And I just gave a presentation in Bristol on Thursday, and there was a doctor in the room, and he came over to me after the presentation and said that day he had had 2 verification jigs that didn't fit. That was a bad day in the clinic for him, because ultimately he knows that he's going back to square one and starting that process over again to get an analog verification jig that will fit. So this is one of the downsides to an analog workflow, that we can get all the way through to the end and still not have the outcome that we're looking for in terms of accuracy and precision. Now let's compare that to iCam true photogrammetry. What does the workflow look like? One of the most important parts of this process is the ability to capture your preoperative data and send that to your lab. Okay, so when the patient comes in for consult and they accept treatment, you take an intraoral scan of the upper, the lower, the bite. You take photographs. You can take a cone beam. You can take your upper, your lower, your bite, and you can send all of that information to your lab. I just did this recently with a new iCam customer in Liverpool who works with Vivo Lab down in London. He had sent all of the information to the lab ahead of time. They had created their digital wax up. They had sent it back to the doctor. The doctor had approved the digital wax up. So essentially, they knew what the temporary prosthesis was going to look like prior to the surgery taking place. Okay. Then the surgery is carried out, whether that's guided, whether that's freehand, it doesn't matter. But now comes the important part of collecting our implant positions. So we already have where our original dentition was from the upper, the lower, the bite. We send that to the lab. Now we need to record where our implant positions are. So the first thing we do is we place our iCam bodies. Okay, this plastic contraption here is the Optragate from Ivoclar. We really like this. It retracts all of the lips and the cheeks out of the way and really gives you a clear view for seating and placing your iCam bodies. Notice as this surgeon places the iCam bodies, the flap is still open. And this is actually a technique that we recommend. We want to verify that the iCam body is completely seated onto the MUA before we take our measurement. Okay, we don't want any tissue impinging at all or stopping that iCam body from seating. So our flap is open. The blood that you see there at the bone level won't impact the performance of the iCam like it would with an intraoral scanner. And we know that we've now seated all of those iCam bodies onto the MUA correctly. Notice in the patient's lower right, the two most distal implants are very, very close to each other. They're almost overlapping. It would be very challenging to pick that up in an analog workflow or a intraoral scan workflow. But when I move forward to the iCam measurement in a moment, the iCam has no issue picking up those two implant positions. So here we've got the Optragate in the mouth. The surgeon is orbiting around the patient. Notice in the bottom image there, the iCam had absolutely no issue picking up those two implants that are right on top of each other pretty much. And I have timed this before. This is about a 19-second scan. So that is how quickly the iCam measurement is taken surgically or clinically right after the surgery has taken place. So we now know to the highest level of precision and accuracy where our implants are. And Dr. Rob is going to show you some cases in his portion of the webinar this evening. The next stage is we seat our iCam refs. Think of these as just healing caps. We'll seat these, we'll suture the tissue, and we're now going to take an intraoral scan of the tissue. Notice in the maxilla here, we've got a reference. Okay, this was placed when the patient had been numbed. This was placed in the palate, and this will act as a reference for our before and our after scans. We need something to essentially align the data against, and this is how we know once the teeth have been extracted where everything is and how to align everything properly. So we've got our iCam data on the right. We've got our intraoral scan data of the soft tissue on the left. This information is sent to the lab. The lab will now align these files together and bring them in to their preoperative designs that we had. And these are just the different files that are needed, the preoperative information, the post-op data, everything is sent to the lab. The lab can then add those implant positions in, send them back to you, and you're able to actually print off that prosthesis in 20 to 30 minutes. And the patient can actually leave within about an hour of the surgery being completed with a printed provisional. And the cost of that printed provisional is about £25. So when I talk about speed with iCam, it's not just how quickly we can take our measurement, but also how many steps are in the process. If you think about the analog workflow, there are a lot of steps, a lot of appointments for the patient, a lot of chair time for you, and a lot of that is eliminated with the iCam and moving to iCam True Photogrammetry. So to summarize then, as I wrap up and hand off to Dr. Rob, why iCam photogrammetry? If someone was to stop me in an elevator and say, why an iCam? What is it about an iCam that why should we look at implementing this into our practice? I would say it's fast, it's precise, and it's easy to use. We talked about the speed to place your iCam bodies, very, very simple and straightforward to place those. Unlike other systems on the market where there's a technique to how you see the scan body, and it can be very convoluted and challenging and time consuming. The measurement itself with iCam is very fast. This particular scan was less than 20 seconds. So it's quick to place the iCam body, but it's also very, very quick to take the measurement. But that's not really the full story of efficiency. The full story of efficiency is how many steps in the process are there. This was a photo that I took at a trade show in Italy recently at a presentation conducted by a lab, where he was talking about his old workflow that required a lot of checks along the way, which are those green checks that you see there. And now his current workflow, which is the workflow at the bottom. Because he knows he has the highest level of precision and accuracy, he doesn't need those checks as he takes the patient from implant placement to the final prosthesis. This is from an analysis that we did for a group in the US who had a traditional workflow. So when we assessed their traditional workflow, their total time from patient consult to final delivery was on average about 11 and a half hours. When they implemented the iCam, they saved about 46% of time. Let's round up and call it 50%. What it meant for them as a full arch group was they could now complete 2 arches in the same amount of time that they used to be able to complete 1. Okay, so when you think about the time savings and the efficiency gains that they had, it really allowed them to grow their clinic and their practice because of the procedures that they could add to their repertoire. The other thing to think about is the cost associated with completing cases in the analog workflow. Analog is quite expensive. All the trays, the components, the copings, that all adds up. And for the same group, we did an analysis for the parts and pieces needed for analog versus traditional. And we found that iCam was about 40% cheaper than an analog workflow when you amortize it over 3 years. So you've got the 50% time saving, but you've actually got a 40% cost saving comparing iCam to analog. Let's talk about precision. I'm going to try and move through this quite quickly. When you talk about intraoral scanners are designed to scan teeth. They're looking for flat surfaces, buccal, lingual, and occlusal surfaces of the teeth. I mentioned at the beginning of the presentation, I worked for Dentsply Sirona. I played a role in the US to launch PrimeScan. And we were trained on the unit in Germany and how it basically works by looking for flat surfaces of teeth and measuring those flat surfaces. Well, what do we not have in full arch implant dentistry? We don't have any teeth to measure. So one of the limitations with using an iOS for a full arch measurement or impression is that it can quite often have a lot of inaccuracies in the information that it's taking, versus the iCam on the right side of the screen there, where it's taking a lot of information and data at the same time. So Boston University, Harvard University in Boston wanted to test this theory. And they wanted to look at the difference between intraoral scanning and iCam. And so what they did essentially is they wanted to measure the performance of each system. And they realized that there's actually no way to measure accuracy. But what you can measure is precision. Okay, and accuracy cannot be better than precision. So the way that you do that is you simply take multiple images of the same condition, and then you overlay them over the top of each other, and you measure them, and you look at how precise they are. And if they're precise, in theory, each measurement should be the same. So they conducted a trial where they had 20 patients, and each patient was measured 5 times with the 3Shape, 5 times with the iCam. And the outcome was quite telling in terms of the data. So I won't spend a lot of time going through each one, but I'll just talk about the cross-arch distance and the virtual Sheffield test. Cross-arch distance using the iCam, the mean average was about 10 microns. Okay, the maximum deviation was 68 microns. But look at the difference between iCam and the 3Shape. The the 3Shape mean average was 90 microns, just in the method in which the measurement was taken. And remember, our threshold that we agreed upon at the beginning of the presentation was 100 microns. So if just in the process of taking the scan, it's 90 microns off, that can lead to some inaccuracies. But the maximum deviation was actually almost half a millimeter, 460 microns with the 3Shape. If you then look at the virtual Sheffield test, which a lot of people regard as the gold standard for calculating passivity, the mean average with the iCam was about 38 microns. The maximum deviation was 173. And something to point out here is this is actually an older version of the iCam. It's the generation 2. We now work with the generation 5. But look at the difference between the 3Shape and the iCam. The 3Shape mean average was almost half a millimeter of deviation, and the maximum deviation was 3 millimeters, 3,000 microns. This is one of the challenges with using intraoral scanners for full arch implant positions. The final thing with iCam is it's extremely easy to use. Dr. Rob will speak about his clinical experiences, so I won't spend a lot of time here. You can see taking the measurement, very, very straightforward, very, very fast and efficient, easy to delegate to the team. Just to summarize here, why iCam? Long history of success, more than 2 million cases completed with no failures. There are a lot of systems that are now coming to the market. They are brand new. They've only been in the marketplace for a year, maybe 18 months. And so we don't really know what the long-term success of those products will be, versus with the iCam, where we've got more than 2 million cases with no reported failures. We've got our unrivaled guarantee. We guarantee a passive fitting prosthesis as long as our IFUs are followed. And our customers often report this to us, so they never have to worry about it being passive or not. Another interesting stat is the DSO usage of iCam, both in the UK and US markets. About 95% of full arch DSOs have iCam that they use in their daily clinic. And that's quite a telling stat, because DSOs typically look at ROI and they look at clinical outcomes when they assess any piece of technology. And these DSOs have looked at all of the different products on the market, and they continue to invest in iCam, which is quite a telling stat. And then, obviously, as mentioned previously, we have those significant time savings: 46% less time with iCam compared to analog, 40% cheaper to use iCam compared to analog components. And typically, the break even with iCam is about 8 cases. So, quite a compelling story or reason for considering iCam for your practice. So, with that, that is the end of my portion of the presentation. I'm now going to hand you off to Dr. Rob Jung. Dr. Rob is a London-based implant surgeon whose practice is focused almost entirely on full arch implant rehabilitation. Over the last 6 years, Dr. Jung has completed close to 1,000 full arch cases, the majority delivered using his fully digital workflow. He has also owned and run a digital dental lab, working with multiple 3D printing systems and milling his own zirconia full arch bridges. In today's session, Dr. Rob Jung will be sharing how he uses Imetric photogrammetry daily in real full arch cases to improve accuracy, fit, and overall predictability. So with that, I will hand off to Dr. Rob Jung.
Thank you, Gareth. Good evening, everyone. It's going to be very difficult to add anything new to this evening's after such a thorough presentation that Gareth gave. Pretty much mentioned everything that I wanted to say. But today I'm going to just show you guys my journey in full arch implant workflows. So without further ado, okay. Can everyone see my screen? Are we okay? Great. So, topic of my presentation is digital workflows in full arch implantology. So a little bit about me, for those of you who don't know me. My name's Robert Jung. I graduated in the Medical University of Łódź in Poland in 2016. Yeah, in 2018, I worked in a mixed practice in Hertfordshire, mixed NHS practice. And then in the middle of COVID, I decided to take the plunge and become a practice owner in Peterborough. I did that for about 3 years, and then I sold my practice. And then I became an associate, and that's when really things took off in the volume of full arch that I was doing. To the point where I decided to open up my own dental laboratory in 2024 called 3D Tooth Lab. And I'm a KOL for both Medit and Apply 3D. So my digital full arch implant workflow journey. It all started in 2020, where I was browsing through Facebook and came across this 3D printing dental group. And the founder, Rick Ferguson, was showcasing how to use hobby printers that you can purchase off Amazon and print full arches. So immediately I thought, okay, this guy has hacked it. So let's dive in. And I think I must have purchased about 20 of these frozen Sonic Mini 4Ks at the time, and then the Mini 8KSs. And then that's how we were printing our full arches back then. I acquired a Medit i500 back in the day, so I've been following Medit for a number of years now. And I always said to myself, the moment I have the funds to purchase this scanner, I will do so. And I've been with Medit ever since. So I've got the Medit i500, the 600, and now the various versions of the i900. So this was what I posted in 2022. This was my first full arch printed on the Sonic Mini 4K with a print time of 1 hour, 6 minutes. Okay, so those were the beginnings. Oops.
Hey, Rob. You need to share the presentation so everybody. You need to show the presentation so everybody can see.
Okay.
Otherwise, they can see only the first slide.
Okay. Sorry, guys. Is there? I think there's an issue with the sharing.
If you have a Mac, do Command F. You should go full screen.
Full screen.
I think you're doing the presentation mode, so I only see. Now I can see your slide 7, but we just see the first slide. We just saw the first slide.
Is that better?
Now I can see. Okay, now you're off. Let me share the screen again.
Is that better?
Here we go.
Okay, thank you. Sorry, can everyone still hear me? All okay? Sorry for the bit of technical difficulties there. I'll skip right back to the beginning. You've heard my introduction. I mentioned about the 3D printing group here. The first scanner that I purchased, the Medit scanner, the first full-arch that I printed. And this is a video of the first lab that I had in my practice in Peterborough. So you can see here that we have a liner trimmer, followed by the numerous different Sonic Mini AKSs. We have an exocad designing station, a light cure station, and during those years we were fabricating our own aligners as well. So you can see the models and the aligners that were being trimmed out. Our thermoform forming machine, and more printers. So you can see I had a little bit of an addiction when it came to 3D printing. So I'm just going to show you guys the first ever double arch workflow that I used using a digital workflow. So I used at the time these scan bodies made by Jonathan Abenheim. These were called THS caps. So in essence, these sit on the multi-units, and you're able at the time to capture the temporary teeth, the position of the implants, and the bite all in one sort of scan. So this is Mina. So Mina presented to me with advanced gum disease on both the top and upper and lower arches. So we performed the surgery, we placed the implants on the top, we placed the implants on the bottom, and at the time we were utilizing this old school method where we were relining our tempories, our hollow tempories, cementing them on, and within that one Medit scan, we were able to capture the tempories, the position of the implants, and the bite, so then our designer could convert this into a screw-retained restoration. This is what it looks like in exocad. So we have a good AP spread of a little tiny cantilever. And this is the result of the bite.
Bite together. Oh, look at that. Spot on.
So I would say it's very nice. I always get a good feeling after watching that video because it's very rare that I achieve those bites using those workflows, especially with an intraoral scanner. But you can see here the before and after. And the total treatment time, I would say, for this patient was maybe 10 hours and multiple visits of trying different temporaries, lots of different adjustments. So in that particular case, I used one particular set of scan bodies. Then I moved on to these horizontal scan bodies. So I used the EasyRef scan bodies, which you see there on the left. And there are other companies out there who, in essence, make the stitching a little bit more accurate. However, the issue then comes in, how do we get a good, repeatable, stable bite? So in the year of 2024, I was doing about 8 to 10 full arches a month. I felt like, everything's going great. I'm on fire. My mission was to solve the world's biggest problem, lower the cost of full arch for both dentists and the patients. And I sort of dived in and used what was advertised as a permanent 3D printing resin material, highly filled ceramic, thinking, okay, well, I can, serve these patients, and help more people. And then that's when lots of issues started happening. The phone couldn't stop ringing, bridges were breaking, patients were losing their teeth in important lunches. Some were swallowing broken bits of teeth, they lost color. And I had to, there was only so many times that you could replace these bridges like for like. You have to deal with the patient stressing them out. They have to take time off work. You're constantly on alert all the time, super stressed. I found it very difficult to sleep. Forget about the amount of money that I had to sort of shell out on reprinting, the time lost in the chair time. My team members thought, okay, what's happening to Rob? His work is constantly failing. So yeah, something had to change. And then, I'm sure most of you know this Dunning-Kruger effect, where at that point, my confidence was sky high. I felt like I cracked the matrix, but I actually didn't know a great deal about passivity, material, science, and that's when I really sort of learned the hard way. So I had this dilemma. Do I send all of these patients to the lab, external labs, where we all know how expensive some of these zirconia restorations can be? So at the time, it was about 80 cases that this happened to me too. And the lab fee was in the region of about 300,000. Or do I open up my own laboratory for a third of the cost and wiggle my way out of this self-made grave? So in 2025, in central London, I built my own lab. So I had my assortment of 3D printers and ultimately milling machines that I purchased to control the costs. So what do I use today? I'm happy to say, by the way, within 6 months, I managed to fix everyone up. So everyone is happy and no bridges have been broken since. So what do I use on a daily basis? I use a MacBook Pro together with my Medits. The wireless version of the Medits now, they work with the iPad Pro. So working in the multiple clinics, it's super portable and super easy. And I've owned probably around 30 to 40 different types of 3D printers. And the one that stood out for me is the Dentafab Sega. This is an affordable printer, probably one of the fastest on the market. We can print a full arch in anything from 8 to 18 minutes, depending on the resin that's used. So it's perfect for same-day full arch prints, or even if you're delivering a temporary the next day. At the end of the day, you want something that's reliable and that it's going to print. And honestly, out of all of the printers that I've tested, this is so good that I actually own 3 of them. So that's how good it was. And I'm not paid by this company or sponsored by them, but I will always shout out about them from the rooftops. If you want to get started into 3D printing, then a low-cost sort of barrier of entry is one of these sort of Sonic Mini AKSs, where you can sort of try and give it a go and see if you want to bring 3D printing in-house. So this is just a quick video of how the zirconia is milled. So the zirconia is milled in a green state form, and that basically means that it's in a chalky state. Once you sort of cut this bridge out, you put it into the sintering machine, and that sinter, everything shrinks by about 25%. And this is the stage where you start coloring the bridges with liquid ceramic, and then you put it to bake. So the whole process from milling takes about 4 hours for an arch. Sintering takes about 12 hours. and then you have a couple of goes at layering with the liquid ceramic, and that will probably take about half a day. But then you're left with a beautiful bridge like that. So in my journey, I started off with a scanner, then I acquired the 3D printers, then I acquired the milling machines, and then to add to this collection, I then came across and decided to take the plunge with the Imetric photogrammetry. If I had the choice to do things again, and with the benefit of hindsight, I would change that order, and I would actually start with an intraoral scanner. Then I would have purchased the Imetric photogrammetry system. You can choose to 3D print in-house, or you can outsource that to your laboratory if you want to. And then the milling machine as well. If you want to bring that solution in-house, that's also fine. But logistically, you have to employ more staff, so there's more sort of systems that you have to create to manage all of that. So how to be sure that your full arch scan data are accurate? Quite simply, when I came to this course that was run in Vivo, I heard Gareth speak a couple of times, him talk about the Imetric photogrammetry. The penny dropped for me, because I realized that there's no other system out there that can match the accuracy of the Imetric photogrammetry. I mean, when I mentioned the photogrammetry to my mum is a land surveyor, and she uses photogrammetry in land surveying. And she explained to me that, you need a minimum of 3 cameras in order to triangulate the coordinates of something. So from the very get-go, anything that has 4 cameras or three cameras or less, it's not good enough in my opinion. So Gareth very kindly went into a lot of detail and spoke about error stacking. So every step we are introducing errors, and we want to sort of minimize this error stacking as much as possible. So what's unique as well, and about the inserter system and the Profilo implant, is when you're actually inserting the Profilo together with your implant, you're actually talking that Profilo into the implant and getting a true seal. So there's not really there's no loosening that's occurring once that implant is in. So with traditional multi-units, you will get a little bit of screw loosening after a couple of months, in which case you have to bring the patient back, re-torque the multi-units, retake another set of ICAM data. Whereas with the inserter system combined with Imetric, the day of surgery, provided you get really good torque, that implant isn't moving. And that also means that we can actually move to our finals a lot quicker than traditionally that we used to. So Gareth, again, he mentioned about the titanium alloys, alloy scan bodies, which don't deform. They're narrow and vertical for that very reason. There's 4 cameras in an aluminium housing that's warmed up to the same temperature each time, so that those 4 cameras can triangulate the dominoes. Before each acquisition of the Imetric data, you have to calibrate, and this calibration literally takes 10 seconds. And the good thing about Imetric is that whether it's yourself or your nurse or the other nurse or a trainee nurse, everyone will capture the same set of data. Contrary to an intraoral scanner, it's all very dependent on scanning technique. As dentists, I'm sure we scan every single day. A lot of us are confident in our abilities until you actually compare it with the Imetric photogrammetry, and you realize that even when you're scanning an upper arch with the best of intraoral scanners, you will be off by a couple of, in some cases, quite a considerable amount when you compare and bring in the Imetric photogrammetry system. And I've done a couple of tests where I've seen, I consider myself to be a pretty good scanner, but even in an upper arch, which is an easier arch to scan, I was off by, sometimes 1 millimeter. We can't expect our restorations to be passive when we're just relying on an intraoral scanner. So why did I decide to buy the Imetric ICAM as an associate? So after the experience that I went through, where I in essence had to fix every single patient that had a broken arch, I didn't want to go through that again. So whether you're doing a high volume or a low volume of cases, the most expensive part of our time is the chair time. We don't want to be sort of adjusting things. We don't want to be repairing bridges or replacing implants and having to start everything from the beginning. We don't want that headache to sort of appear in 5 to 10 years' time. And after personally sort of restoring almost 1,000 arches now, I can feel that the ones that I just relied on an intraoral scanner, that they weren't passive. And sometimes there was this feeling that I was making things fit. And the moment I purchased that Imetric scan, I brought those patients back, took a new iCam, did a quick redesign, and then through my lab, I was able to sort of fix them up and give them a zirconia restoration and sort them out that way. Patients deserve to have passive fitting bridges. And the question I sort of ask myself, what would I want my mother or my father to have? And I think for 20 to 30,000 pounds, the investment is definitely worth it. So I'm going to show you a clinical case where passivity is absolutely key in this particular case. And this is my patient, Corinna. So I don't have her CT with me on this presentation, but she basically had 0 bone. Zygomatics were an option, but in this particular case, we decided to go for the subperiosteal implant, which is a bespoke custom-made implant that essentially sits on the maxilla. So there's no room for error with these cases. Otherwise, it's just an absolute nightmare if you have to remove one. And yeah, ask me how I know. So in this case, we actually started off by placing the pterygoids. We let them sort of integrate. This is just a quick video of the insertion of the bridge. So there's no room for error with this. If you're screwing in this bridge and you're creating tension, almost definitely it's going to fail within a couple of months. So everything had to be spot on. We then move on to the acquisition of the iCam data.
Yeah, a bit more. Close a little bit.
Yeah. So already ergonomically, I'm in the wrong position. I would recommend to bring the laptop in front of you and also to have the laptop plugged into a charger to get those timings of 20 seconds. So this took about 20 seconds to acquire the Imetric data. So yeah, ergonomically, I was in the wrong place. But yeah, afterwards, we follow up with a little bit of red light therapy for the patient. And whilst this is happening, we have our design. The design takes about half an hour to design, and then the Dentafab comes to the rescue with a 15-minute print for the upper arch. Then we have to, of course, post-process. So we remove the supports. And then we very quickly use a little bit of glazed material. And this is how it looks like after fitting.
Together. Open, close.
And that's how she looks like. So yeah, really rewarding case for her. So I'm going to talk a little bit about markers. But before I do, this is another case. This is a patient called Cash, a very young guy, aggressive perio, hadn't been to the dentist for 15 years. was desperate to do something about his teeth.
Open and close. Open your mouth and close.
So again, we acquired the data with the Imetric.
Onto the laptop.
So I still hadn't learned my lesson with the ergonomics, but this is where we are now, as of the other week, with this with this workflow. And yeah, he's looking a lot better, feels a lot more confident. And what was really rewarding, and I didn't realize how much of a difference we were making to people's lives, but he would say to me that for the first time in 5 years, he would have kissed a girl. So happy days. And this is just the X-ray. So these are some other real-life cases where we introduce markers. So you can see there that we place a marker into the palate. So this, as Gareth mentioned in his section of the presentation, it acts as a common reference point. And I decided to keep the 2 molars at the back as reference points. So the upper arch, in this case, I used the EasyRef scan bodies. So the upper arch is actually easy to scan. It's not a problem. The issue comes with the lowers, where you've got a lot of soft tissue. There's not much. There's not really a pathway. That's why sometimes these scan bodies, they can help these horizontal ones to sort of stitch them together. But I certainly wouldn't rely on them to give me a passive final fitting restoration. So this is how the lowers looked like. Again, it's very difficult to scan the lower arch day of surgery. And this photo was taken after a couple of adjustments and redos, because almost definitely with a scan like that, it's very difficult for the designer to marry everything up when you're reliant on soft tissue as your common reference point, and even 2 teeth at the back.
Open and close. Open and close.
Here's another case. This is an upper arch, pretty straightforward. So this is our preoperative situation. When the patient comes in on the day of surgery, I numb them up on the top. I digitally remove the palate, and I take my scanner and scan over that area again. And then we're left with that marker there. Okay, and then we take another additional scan, and that marker in the middle of the palate is our common reference point. And then we're left with a very nice bridge like that. Okay. Scanning the lower arch is very difficult. As I mentioned already, this patient, although she needs both arches done, she opted to do the lower one. And again, by some miracle, we were able to go from this situation to this situation with just purely reliant on soft tissue as the reference points. I didn't actually use any markers in this case. But again, this is all guesswork, and it's not consistent. So this ill-consistency in these types of surgeries, it's certainly stressful, and we want to simplify things and make things a little bit more consistent. And I've borrowed this slide very kindly from Ryan Dunlop, who's an implant surgeon in America. And he runs a group, Full Arch Masters. And here he's shown how he's actually triangulated the mandible. So he's placed a marker in the lower, in the retromolar area, and one down in the bottom, near the chin. And you can see that with an intraoral scan, once you start your scan from one side, the scanner actually warps and it distorts the image. So again, being reliant on an intraoral scanner, it's just not accurate enough. And you can see that when you superimpose the 2 images on top of each other, it's not accurate. So in situations like these, I've sort of reverted to just taking an impression. And I've spoken to Gareth many times that actually taking an impression is more accurate than taking an intraoral scan. And yeah, when I'm doing these cases on the lower, very often I get these messages from my designers. This is very difficult to align the both, even when I've taken an impression preoperatively and trying to match the soft tissues or the markers at the back. This is the best fit match that I've received. These are all common complaints that I get from my design. It's incredibly frustrating. You can do the best surgery, but then things just fall apart at the design and delivery stage. But still, once you have a reference and you sort of get the bite 80% there, you can always adjust and then bring the patient back in, and then you get closer to the home. But again, we want to save time. We want to sort of reduce the amount of appointments for us and for the patient. So this is a case that I did about 2 years ago now, where we've taken the patient from, as you can see on the left, to the right there. Here we have Linda here. So again, similar workflow. And this is Dawn. This is a very rewarding case. Very high lip line, lower denture, and we managed to sort of convert her like this. So all these cases that I've shown you so far, they look great, but I'll be completely honest, they took a very long time to achieve these results. A lot of sort of trials and retries, and they weren't profitable at all. They may look great on Instagram, but they weren't profitable. So that's another reason why I want us to sort of purchase a piece of equipment that would shorten the appointment and increase the accuracy of the data that I was getting. So this is a patient that I treated a couple of weeks ago. Stephen, this was an upper arch. So again, he presented to us with failing dentition.
Showing your teeth, yeah.
So we take our photos, we take our intraoral scans of the top and the bottom. We did this partially guided. So we had some guides fabricated by Vivo Dental Lab. And in this photo here, you can see the avioplasty that I had to perform, and with a stackable option to guide me with the implant placements. Now, my design, I send all of the information to my designers. So I place the ICAM intraoral scan body scans, and this is the process of how he aligns everything with the intraoral scan. So he identifies the implant and he has to align them together. So you can already see, even on the day of surgery, where there's a little bit of blood, a little bit of soft tissue, because of the technology of the intraoral scan, we're stitching lots of images together. There is going to be an element of inaccuracy. So having a digital verification system like Imetric just gives you that peace of mind that it's just, at this moment, it's actually correcting the position of the multi-unit. So then we know that we're going to get a super, super passive restoration. So having a digital verification system like Imetric just gives you that peace of mind that it's just, at this moment, it's actually correcting the position. So you can see there, despite my best efforts, right at the back of the mouth, we managed to align all of that data. Okay, now I'll move on to the design element. So this is in Exocad. So this is the process of how he designs the teeth. So he's taken the preoperative situation, and he will bring in my the scan with the palatal marker, and he will superimpose the two on top of each other using the teeth in this case as the common reference point. So he's taken the preoperative situation, and he will bring in my the scan with the palatal marker, and he will superimpose the two on top of each other using the teeth in this case as the common reference point. Okay, and now at this stage, he brings in the intraoral scan of the implant positions, or in this case, the Profilo positions, and we use the common reference point, which is the marker. In some cases, you can use 2 markers in the palette. That can provide a little bit more accuracy. Okay. So this is the result. We performed the surgery. We finished the surgery in about an hour and a half. We did the design. We waited for the teeth to print.
Okay, just open and close. Open and close, yep. Open and close. Very good.
And to be honest, I'm very happy with that. Patient's very happy with the aesthetics. So this was the intraoral situation before. This is the situation with the marker. And this is the result straight after the surgery. And then within a week, we converted him into a zirconia bridge. The thinking behind this was to provide him with a material that is super strong, that won't break, that will, in essence, splint the implants together. So he's literally within a week, he's left with a final upper bridge. And at some point in the future, he will decide to do lowers. So the key things to remember: keep your scan to under 1 minute. Otherwise, you're most likely to introduce errors into your scan. Make sure that if you're going to scan, make sure that it's a dry scanning field, that there's no saliva or blood. When it comes to 3D printing, I tend to use 1 printer for 1 dental device. So use 1 printer for models, 1 for surgical guides, 1 for printing same-day teeth. For double arch surgeries, I think we just need to accept that the bite won't be 100% consistent every time. So in those situations, just adjust the bite till it's almost right. Do a rescan, redesign, and then bring the patient back in to refit, and then you take it from there. For the lower arch, I now take impressions and I scan the impressions, as this takes saves a lot of time and stress. So there's one more thing that I need to just mention. So I talked about the inconsistencies of these double arches with intraoral scanners and everything. So we have worked on a new workflow that allows us to scan the lower and the double arches, that we have consistent, balanced bite results, which I'll share with you now, with very little to no adjustments required. So that saves so much time, and in essence, we can go to finals within a week. This is a case that I performed last week, a double arch case. This is the result.
Back together and smile. All in 6 hours, yeah? Nice.
So it took 6 hours because we were waiting for the teeth to be designed and to print, and we had an issue with the printer on the day. So we would have finished this case a lot quicker. But I'm sure you guys can appreciate the bite. There's hardly anything that needs to be corrected here, which is an absolute dream. And when I think about the inserter implant system that we're using, coupled with this new workflow that we developed, we can finish our cases a lot quicker and splint those implants and put patients into definitive restorations a lot faster. And now we got it to a point where we're able to do about 3 to 4 arches a day now, breaking hardly any sweat and getting consistent results. This is another patient that I saw on the 15th of January. He came in and I took this pre-op video at 10:23. Class 3 situation, very difficult to correct. And later on that day at 5 o'clock, we get a beautiful bite like that. Very tiny little bit of adjustment on one side that had to be performed. So we brought him back a week later, and this is this is the bite that we have. So now he's got used to it because of how big of a difference. You know, we've changed his life, his bite. There's a lot of change. I've left him in these for a couple of weeks just so that he gets accustomed to them and gets used to the speech. But yeah, everything went great. The bite was perfect. Little adjustment. So we just took a scan of that, asked the designers to just tweak the design a little bit, but not too much. And now we're ready to proceed to the finals pretty much. So stay tuned for the courses that we're going to be announcing in 2026, where we'll be talking about this workflow. And if you're interested, then just send an email to education@inserteddental.com. So that brings me to the end of my presentation. And I think we have a Q&A session. Thank you, everyone, for spending your evening with us.
Thank you, Dr. Rob. Really appreciate you covering that. Can you hear me okay, David? Okay, great. So thank you for that presentation, Dr. Rob. That was fantastic, and really appreciate you sharing your clinical experiences with iCam as well as the other technologies. It was very, very helpful. We did have one question come in around one of the other systems on the market and some of their claims around accuracy. And Simon's done a fantastic job of fielding some of those questions, but I wanted to very quickly just quickly show you a slide here from the Harvard study that I referenced earlier. So Simon kind of spoke about it, the difference between precision and accuracy. Okay, so let's think about, you've got 3 targets on the screen here, and we're aiming for the bullseye with our target or our shots essentially. If we look at the far left one here, are we accurate with our shots here? Absolutely not. We're nowhere near the target, but we're precise. We're hitting the same point over and over and over again. With the middle target you see here, our accuracy or trueness is better. We are hitting the bullseye more frequently, but the shots aren't as clustered as closely together. And then on the right side of the screen here, we've got high precision and high accuracy. So when someone talks about a product being accurate, it can certainly be accurate based on the type of, I've got to be careful how I phrase this. It could be accurate based on the methodology that they use, but accuracy cannot be better than precision. And accuracy actually is very, very difficult to test, because ultimately when you test accuracy, you're testing an outcome against an initial situation, which can actually be hard to measure. So if precision is always better than accuracy, and accuracy is hard to measure, why not measure precision, which is what Boston University or Harvard University did. So my recommendation with the other system on the market that uses the horizontal targets is there's a few things with that. Number one, it's still using an intraoral scanner. And Dr. Rob did a fantastic job a moment ago of explaining some of the limitations with the iOSs, in that everyone on this call could take a scan of the same patient and everyone's model would be different. And it doesn't matter the methodology you use. Horizontal scan ladders, scan bodies, it doesn't matter. You're using an intraoral scanner to capture your information. And based on how long you spend on the buccal, how long you spend on the lingual, going to the occlusal, how much time your scan takes will determine the level of accuracy and precision that you have. So that's kind of the first thing. Second thing is, whenever you have a horizontal target, you're always going to get some fluctuations and some challenges with the accuracy across that target. In Photogrammetry 101, Horst will tell you that they're trained that targets should always be vertical. They should never be horizontal, because when you measure something that's horizontal with photogrammetry, you're going to get discrepancies there. And then the third piece is obviously so we've talked about the inaccuracy or imprecision of intraoral scanners. We've talked about the horizontal scan body. We've talked about everyone's scans being different based on how they measure. The final thing I would say is if you're looking at different systems on the market, or you're evaluating different products, the best thing you can do is do exactly what Harvard did. Whatever product it is you're looking at, take 2 scans or 2 measurements with that product, and we can actually help you evaluate the level of precision. All you basically do is you take your 2 scans or 2 measurements and you put them on top of each other. In theory, if your measurement is precise, they should be identical. Okay. but what you typically see is a slight shift, a slight difference between the two. And when you're in that situation, which one is correct? So my recommendation in that situation is, trial some of the other products out there. Take 2 measurements. Dr. Ryan Dunlop, who Dr. Rob mentioned in his lecture, will be speaking at the Lab Day event in Chicago in a couple of weeks on this very topic, that if you're unsure, if you're looking at different products or evaluating, simply take 2 measurements with that product, and we'll help you analyze the precision, and that will tell you how precise it is. And if precision is always better than accuracy, it'll give you a good understanding of how well it works. So I just wanted to cover that to answer the question that came through from one of the attendees. Were there any other questions?
I think there was one about, I can see here, from Dr. El-Adawi. Thank you for your question, Mahmoud. He said, how would you take the bite when the patient is edentulous? Well, you have to find, you have to sort of calculate the vertical. So you can do that with dentures, or even stacking up with gauze. But I strongly recommend for you guys to come on to the courses that we're going to be running, because what we have in stock, it's going to blow your minds, and will save you a lot of time, a lot of time. And yeah, take it from me. I've wasted a lot of money, a lot of time, a lot of stress, time away from home, figuring all of this stuff out. So yeah, just we will we will share all of the workflows in great detail there.
Excellent. Thank you, Dr. Rob. Well, if there are no more questions, I just want to take the opportunity again to thank everybody for attending the webinar this evening. Hopefully you found it informative, and it maybe answered some of the questions you might have around photogrammetry in the full arch space. If you have additional questions, please reach out to your local inserter representative, and they will obviously get you the answers to those questions. But thank you again for your time. Thank you again to Inserter for hosting this event, and all the team behind the scenes that have been working on this. And have a wonderful evening, and we look forward to seeing you at a course potentially soon. Thank you so much.
Thank you, guys. Have a good evening.